All right, today we are getting into long division with polynomials, and to start with long division, we need to think about long division from elementary school. Here we have a very simple 13.22 divided by 10, and just to throw back and remind us how to do long division at all. Now, I know some of us have our tricks and we can just move the decimal place over and be done with this problem, but I want to go through the long division process and consider the algorithm in a fresh new light. So first of all, you put your little division symbol and put the numerator inside. So 13.22 goes on the inside, and then the 10 goes on the outside. So the way that long division works from elementary school is you're supposed to look at this number 10 and decide what's the first set of digits that it can go into evenly. And I'm going to change that a little bit today. I'm going to ask you a different question and make you think through a different question. Is you want to put up top a number that multiplies by the number out in front, the 10, to get as close as possible. And with our polynomials, it has to be identically the same to this number on the inside. So we're going to take 10 and times it by a 1 to get as close as we can to the 13, and that's 10. Now, in elementary school, you then learned that the next step was to multiply this value by a negative and then add. Just kidding, you were told to subtract, but I'm changing it because we've got to think about polynomials. What's happening is you're actually multiplying by a negative and then adding integer values the way they were. We just, you couldn't tell you that when you're in the elementary grades. So here we are, 13, and we're adding a negative 10, which means we actually get a value of 3. And then we learned that we were supposed to bring down the 2. You were supposed to bring up the decimal right there. And then bringing down the 2, we reconsider again. What do you multiply 10 by to get as close as possible to 32? And the value would be 3. And then I'm saying today you take the 3 and times it by the 10. So 3 times 10 would get you 30, and you put that result down below, 30. And then we take that 30 and multiply it by a negative value and add. And I know that should sound abrasive to you because your brain says, no, you just subtract. I know. And then we take the 32 and add the negative 30, which gives us a value of 2. And bring down our final 2. And what's going to happen is we consider what do we multiply 10 by to get as close as possible to 22, and that value is 2. And then take your 2 and distribute it to the 10, and that's going to get you a 20 down below. And just like elementary school, just kidding, we multiply this by a negative and add, and that gives you a 2. Now this 2 is your remainder. Now, we're going to take care of that a couple different ways. In elementary school, we would have learned you put a 0 down there, bring it down. But I'm actually going to say, hey, that's my remainder. And you had a little r actually in elementary school probably. And so you might have put like an r, and then you put your value. Okay, well, one step past that moment where you put r and then the value, you learned that you could actually say plus your remainder divided by what you were dividing by. In this case, the 10. So we would put the 2 over 10. And that's going to help us today for the way we write things. Now, I know we can reduce that to 1/5. Again, I'm trying to make an example out of just what would have been a very simple moving of a decimal for a result. So our answer is 1.32 plus 2/10. And of course, 2/10 is 1/5, which is another, you're just going to get another a value of 2 at the end if you wanted to continue the decimal. But the point is today we're working on connecting this to long division with polynomials. So this is how our polynomial quotients will look.